Alright, this video will go over angles and how we measure them. But before we get into how we measure angles, let's go into some basic definitions. A ray has one endpoint and extends indefinitely in one direction. If you want to know what that looks like, it looks like this, sort of. An angle is just two rays joined at a common endpoint. So if you had this ray and this ray, what you have in between there is an angle. And oftentimes for an angle, we'd like to use the Greek letter theta. Now, when measuring angles, we normally go in a clockwise motion, or a counterclockwise. The side where we start is what we call the initial side. The side where we end is what we call the terminal side. And this common endpoint is what we call the vertex of the angle. You go clockwise, like what's illustrated in red, that would be the negative direction. If you measure an angle clockwise, your measure will be negative however many degrees. Now, standard position on a Cartesian plane for an angle. If you have the coordinate plane, standard position begins with the initial side along the x-axis. The vertex is at the origin, and wherever the angle is, wherever the terminal side is, it measures from the initial side to the terminal side in a clockwise manner. Also keep in mind that the angle, whatever side the terminal is in, whatever quadrant the terminal side is in, we say the angle lies in that quadrant. So for example, what quadrant is this angle in? You know it's in quadrant 3. Now, one of the popular ways we like to measure angles is by using degrees. Now, one counterclockwise revolution is equal to 360 degrees. And we can further break that down. 1 degree is equal to 60 minutes. We can denote minutes with a single apostrophe, so 60 with an apostrophe would be 60 minutes. And 1 minute is equal to 60 seconds. We denote seconds with 2 apostrophes, or quotation marks, or whatever. So 60 seconds, using shorthand notation, would be 60 with 2 apostrophes or a set of quotation marks. So here are a couple of examples. Convert 50 degrees, 6 minutes, 21 seconds to a decimal in degrees. And let's round our answer to 4 decimal places. So we can rewrite this 50 degrees, 6 minutes, 21 seconds as 50 degrees plus 6 minutes plus 21 seconds. So we know there are 60 minutes in a degree, so we can divide the 6 minutes by the 60 minutes in a degree. And the 21 seconds. We know there are 60 seconds in 1 minute times 60 minutes in a degree. So we can multiply 60 by 60 to get the number of seconds in a degree. So that would be 50 degrees plus 0.1 degrees, 6 over 60. Alright, that's 60 times 60 means this fraction would be 21 over 3600. So that means 21 over 3600 as a decimal would be approximately 0.0058. So if you want to add all this up, this would be approximately, that would be an approximation as well because we rounded the 21 over 3600. It would be approximately 50.1058 degrees. Now for part B, we start off by taking the 21 degrees and we multiply the decimal part. We multiply the decimal part by 60 minutes in a degree, and that tells us the number of minutes. And we're gonna round this, our final answer, to the nearest degree. So what we have here is 21 degrees, and it would be 21 degrees 15.36 minutes. Remember, that's 21 degrees plus 15 minutes. We can take the decimal portion, since that's 0.36 minutes. We can multiply it by 60 seconds in a minute. So that would be 21 degrees, 15 minutes, and 0.36 minutes times 60 seconds in a minute would give you 21.6 seconds. So, if you want to round it to the nearest second, which is what we were told to do, it would be 21 degrees, 15 minutes, and 22 seconds. Alright, the next way of measuring angles we're going to learn about, I'm sure you've heard about it before, is this method called radians. Let me show you a diagram of how we get the concept of radians. Alright, when we have a central angle, an angle whose vertex is at the center of a circle, and if whatever length the radius is, if the length of the arc, the outside created by the portion of the outside created by the angle, if the length of the arc is the same as the length of the radius, then however big that angle is, that's what we can say that's 1 radian. And we can say that 1 revolution around the circle in a counterclockwise manner is equal to 2 pi radians. So here's an example of what we mean. If you have a circle of radius 3, say if that radius is 3, when the length of the arc created by that angle is also 3, the measure of the angle is 1 radian. That's where we get the concept of radians from. We said 1 revolution is equal to 2 pi radians. And we also said earlier that 1 revolution is equal to 360 degrees. So we can say 360 degrees is equal to 2 pi radians. So if we want to divide that by 2, we can say 180 degrees is equal to pi times radians. Now if we want to switch between radians and degrees, this is how we do it. If our angle is in radians and we want to switch to degrees, we take our angle, which we're going to denote by the Greek letter theta, we multiply it by 180 degrees all over pi radians. And if we want to switch from degrees to radians, we take our angle theta, multiply it by pi radians over 180 degrees. So, say we want to convert each angle. 60 degrees. When we convert each angle, that means switch each angle to the other form. Since it's in degrees, we would switch this to radians. We would multiply it by pi over 180 degrees. So 60 goes into 180 3 times, so you end up with pi over 3 radians. Likewise, to convert 150 to radians, we multiply by pi over 180. We can reduce the 150 and the 180 by 30. That would give us 5 and 6, so it would be 5 pi over 6 radians. To convert pi over 2 radians to degrees, we have to multiply it by 180 over pi. The pi's would cancel out, the 2 and the 180 would reduce. So that would just be 90 degrees. And those 3 would be our answers. Alright, the next thing we're going to talk about is just the concept of arc length. Alright, Pretty much if you have this portion of the circumference, let's call it S, is created by multiplying the measure of the angle by the radius. Likewise here, for a reason they have a second arc called S1 is equal by multiplying the length of that angle, R, or theta sub 1, by the radius. Remember, your angle is in radians when using this formula. So, let's do a couple of examples pertaining to arc length. Find the length of the arc of the circle with a radius of 2 meters, subtended by a central angle of 0.25 radians. Remember, S is equal to R times theta. Is equal to the radius, which is 2 meters, times the angle of 0.25 radians. So that means the arc length would be 2 times 0.25, which would be 0.5 meters. So, another example would be a word problem. A pendulum swings through an angle of 20 degrees each second. If the pendulum is 40 inches long, how far does its tip move each second? So, and it says round answers to 2 decimal places. So, let's draw a picture. If this is our pendulum, and it moves to here to here, it wants to know how far does it move each second. So we have our radius, if the length of our pendulum, which is 40 inches, and our angle, which is in 20 degrees. So we can find the arc length, let's multiply it, get into radians. So 20 and 180 reduce, so that would be pi over 9 radians. So the arc length is equal to 40 inches times pi over 9 radians, which is approximately be 13.96 inches. So another example is, if I give you a radius of 6 meters and an arc length of 8 meters, what's the angle? So you can plug it into our formula. Be 8 meters is equal to 6 meters times our angle. So if you divide by 6, it'd be 8 over 6 radians, which reduces to 4/3 radians. So now we're going to talk about this concept of sector area. So if we have this area created by the radius in a sector, remember, sector area is just the area created by the sector. So this area is equal, the formula for the area is equal to 1/2 times the length of the radius squared times our angle. Remember, theta is in radians. So here's an example. Find the area of a sector of a circle with a radius of 2 feet formed by an angle of 30 degrees. Round it to 2 decimal places. Remember, 30 degrees, we need to get it into radians, so multiply by pi over 180. 30 and 180 reduced to 1 and 6, so our angle is pi over 6 radians. So the area would be 1/2 times the radius, which is 2, squared times our angle, which is pi over 6. So that would reduce. 2 squared is 4. 2 goes into 4 twice. And 2 goes into 6 3 times. So we end up with pi over 3 square feet, which is approximately 1.05 square feet. So here's another example. A water sprinkler sprays water over a distance of 30 feet while rotating through an angle of 135 degrees. What area of lawn receives water? Alright, you need to change the angle of 135 degrees into radians. Multiply it by pi over 180. Both of them reduce by 45 degrees. So if you divide 135 by 45, you get 3. Divide 180 by 45, you get 4. So our angle would be 3 pi over 4 radians. So if you want to find the area, it'd be 1/2 times 30 squared times 3 pi over 4. Alright, so 30 squared is 900. Divided by 2 gives you 450. So you end up with 450 times 3 times pi, which would be 1350 pi over 4, which is approximately, it'd be approximately 1060.29 square feet. Alright, so if our angle is 1/4 radians, our area is 6 square centimeters, what would be our radius? And that's supposed to be a question mark. So, we can use our formula. Our area is 6. Do 1/2 times our theta, which is 1/4, times our, it'd be radius. Right, no, and it'd be r squared, that's right. So that would be 6 is equal to r squared over 8. Which means r squared is equal to 48. So now, if you want to solve for r by taking the square root, r is approximately 6.93 centimeters. Yes, I know if you're solving for a variable and it's squared, you would normally take the positive and negative square roots. But since the radius can only be positive, that's why we only took the positive square root.